Hi, grade 11s. This is just a recap of your analytical geometry from grade 10. We're not going to be starting on any of the new grade 11 analytical geometry until we see you back in the classroom. That's because there's only one extra little bit that we add on, and we'd rather do it in person. So just to recap here, you have your three main formulas that we worked with: your gradient formula, your distance formula, and your midpoint formula. So the gradient is to work out the slope of a line, the distance is the length of a line, and the midpoint to find the middle of the line. Now, these formulas can be adapted and used in different ways, so I'm going to go through a couple of examples with you, not the whole exercise, but just some that you can work through as examples, and then you can do the rest by yourself. All right, so the first exercise in the PowerPoint is on gradient. So we have your gradient formula, y2 minus y1 over x2 minus x1. So let's do question 2.1.1 together here. It says determine the gradient of the following, and for 2.1.1 it wants the length of AB. So here is A, there is B. All of this can be found in your PowerPoints on Google Classroom. All right, so the gradient, the slope, because it's going down from left to right, we expect to get a negative answer. For the ones going up from left to right, that means it's a positive answer, positive gradient. All right, so we're working with AB. So the gradient of AB, small letter for M, and then you just write AB so you know what line you're working with. Now, here is our tricky bit. Some of you forget it's Y's at the top, X's at the bottom. So it's going to be negative 2 minus 7. So that's my Y value from both. Then you've got to keep it in the same order. So I started with the B's Y value, so I've got to start with the B's X value. So it's going to be negative 5 minus negative 8. So then here I get negative 9 all over. That's going to be negative 5 plus 8 is positive 3. And so that's going to be negative 3. And the gradient should be negative because we have a negative slope. All right, so that is, the rest of them are pretty much the same. You've been given the points. You just have to use the formula correctly. Then for question 2.2, it is a gradient between point A and point B, but you notice that point B has something missing from it, but they tell you that the gradient is equal to 5. Determine that Y value. All right, and then for 2.3, it's the same thing, but you're determining an X value. So I'm going to do 2.2 with you. You can do 2.3 by yourself. So for 2.2, the gradient of AB, right, we know it's going to be Y minus 10, 5 minus 8. It doesn't matter which order you start in. So this is the Y value I started with, as long as underneath it, you start with the corresponding X value. Okay, so if you started with 10 minus Y, you would have had 8 minus 5. Doesn't matter the order. All right, but now we have an unknown, so now we've got to use the gradient that they told us. They told us that the gradient is actually equal to 5. So Y minus 10, 5 minus 8 at the bottom is negative 3. All right, remember that's 5 over 1, so we can cross multiply. We get negative 15 equals Y minus 10. So Y is going to be, take that across, negative 5. All right, so Y is negative 5. All right, so now you can work on 2.1.2 onwards and 2.3 for the gradients. Then for your distance, you've got to use your distance formula. There's two forms of the distance formula. There's the full distance formula, which is actually the following, where you'd have distance squared equals your x2 minus your x1, your y2 minus your y1. But what we normally go to is just your distance and then the square root of those. So x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so it says for 2.1, given triangle ABC with point A, B, and C as given, determine the distance of AB, and then prove that ABC is an isosceles triangle. All right, so let me do 2.1.1 with you. So the distance between point A, which is -5 and -1, and point B is 3 and -1. Now you'll notice their y values are the same, so which means they are actually sitting perfectly in line with each other. So you could also just do the hops 1, 2, 3, 4, 5, 6, 7, 8 units. All right, and because B and C are in line, because they have the same x values, you could work out 1, 2, 3, 4, 5, 6, 7, 8 units. Okay, so that's 8 units. And that's 8 units. And then you could, so you don't have to use the distance formula. But let's just use the distance formula to practice. So that only works for perfectly horizontal and perfect vertical lines. Horizontal share the same y value. You can see there they're sharing that same y value. Vertical shares the same x value. So they're perfectly in line with each other. So for this, let's say the distance of AB, we're going to use the full square root, is going to be, now you're going to take your x values and then your y values. So we're going to have -5 minus 3, -1 minus -1. Right, so then that is going to be the square root of 8 squared plus 0 squared, which is just the square root of 64, which is 8 units, which we did get from just doing the hops. So it's up to you, but for those who didn't see that it was perfectly horizontal, you can just use your distance formula. It'll give you the same answer. So then for 2.1.1, it says prove that AB is an isosceles triangle. Now, in order for ABC to be an isosceles triangle, two sides must be equal. So you can see that we've already figured out that two sides are equal, but what about the third side? So you can use Pythagoras to prove the third side is not equal to 8. And then that is an isosceles triangle where two sides are equal. All right, then 2.2, you can work out the distance between all of those points. That's easy enough. But then for 2.3, this is where they leave out points. So I'll do 2.3.1 with you. The distance between point F and point G, but G has something missing, is equal to 9. So they've told you the distance. Now you've got to work out the missing letter. And sometimes they throw in things that are simultaneous. You've got to just think logically about these. Okay, so if they tell you two lines have the same distance, you can make their two equations equal to each other if they have the same distance. So let's go with the distance of FG is equal to. All right, so then we fill in, just make sure if you're going to use the x as x1, then you must use the -4, its matching coordinate for y1 or y2, as long as they match. All right, so we end up with x plus 3 all squared plus -9 all squared here. So we end up with a foiling situation here, so it becomes x squared plus 6x plus 9 plus 81, x squared plus 6x plus 90, and that is equal to d, the distance of FG, which they've told us is 9. So in this case, what we can do is we can square both sides. So we square 9, and when we square the right-hand side, our root goes away. So then we can bring our 81 over, and we end up back with x squared plus 6x plus 9. Right. So the 81 actually wasn't even needed for both. They cancel each other out. So if we factorize this, we get back to our x plus 3 all squared. So that means we have x plus 3, x plus 3. So therefore x equals -3 or x equals -3. So this must be our value. X is -3. Okay, and then for 2.3.2, you can do that by yourself. The distance between point K and L has a missing y value. So they have told you that your distance is equal to root 45. Determine the value of y if y is greater than 5. So you're obviously going to get two answers and one's not going to work. So check which one is greater than 5. That is your valid answer. And then lastly, for midpoint, calculating the midpoint of the following coordinates. So let me do 2.1.1 with you here. So it is the midpoint of this line, right? You can put in nice big brackets here. It is your two x values added up together. And if you need to label your x and your y, you can do that. So your x values added together divided by 2, your y values added together divided by 2. So then this is going to be 9 over 2, which is 4.5, or you can just leave it as 9 over 2. And that's going to also be 9 over 2, just a coincidence. All right, so you can do the rest of that question. Then for 2.2, it says, given is a quadrilateral DEFG. So that order that they've told you is the order you must draw it. DEFG. Right, DEFG. I just happen to draw it looking like a rhombus or parallelogram. It's just a force of habit. It makes no difference if you are drawing a square or a rectangle itself. Right, and then they've given you point D is -4 and 5, point E is -3 and 6, 5 and 2, and 6 and 6. Determine the midpoint of DG. So here, so find the midpoint of DG, and then find the midpoint of DE. All right, so that's easy enough. What often they can also ask you is to find the midpoint of GE and the midpoint of DF, and you'll find for certain shapes they'll be the same. For example, a parallelogram, a rhombus, where their diagonals bisect. Okay. But we're going to come back to that in a little bit when we get to the grade 11 stuff. So then for 2.3, you're calculating the midpoint D, which is of the line AC, then the gradient of B to D, so you'll find D, and then that will be BD. The equation of BD, now remember that's a straight line. So a straight line is y equals mx plus c. So once you've got the gradient from 2.3.2, then you just need to subs in. So you need the gradient and you need a point. Now you've got point B and point D, and you can solve for C there. And then calculate the distance of AC. All right, so you can now get on with your exercises, your revision, and then have a look at the second part of the revision note pack.